Alright guys, let's continue with the next one. If the object is between 2f and f, it is slightly further than the focal length, but not twice the amount of the focal length. So again, we'll draw the first ray, which will go straight. The first ray will go straight towards the center, which is parallel towards the axis, and then it will go through the back focal point. Second one will go through the front focal point. Again, make sure you draw this accurately. Yes, I don't have my ruler here. Okay, and then the last one will go through the center. So your point will be somewhere around here. So this will be your image. So let's write down the characteristic, which is inverted. It is also real, as is at the back of the lens, and slightly bigger. Let's check our answer then. The image is inverted, correct. Real, yes, and also magnified. Easy, right? Okay, so let's do the next one. Object at focal length f. Now, the object is exactly at the focal point. So what will happen to the image then? Can you do that yourself? Okay, I'll give you 1 minute to complete them. Go. Are you done? Alright, let's do this together. Check the answer. Again, go through straight line or parallel, and then we'll go through F. The next one cannot pass through the front because the object itself is at the front focal length. So we'll dismiss that, but it can go through the center. As you can see, the two lines cannot be connected at the back here. First line, second line. So let's try and connect it at the front of the lens. From here and here. As you can see, it does not meet each other, no matter how far it goes. So this means there will be no image formed because the lines never cross, be it at the back or at the front. Okay, the next one will be if the object is inside f, meaning it is smaller than the focal length. So again, let's draw this straight line, which will go through the f. The second one cannot go through the front f, so you can actually draw it at the center only. And it does not meet at the back here. So what do? Try and connect it at the front. And at one point it does meet. Let's see, this is the point of intersection. So draw your image. Now I want you to write down the characteristic of the image. Can you do the 3 characteristics? What will be the first one? Yes, it's bigger, very obvious, and it is upright. Is it real or virtual? This is the front of the lens, meaning the image is virtual. So let's check our answers. It's upright, yes. It's virtual, yes. And also magnified. So those are all the image tracing for convex lens or converging lens. How about concave lens or diverging lens? Would it be the same? Well, the steps are actually the same. The only difference will be where the image is located. So the first lines that you need to draw, just draw a line, the straight line, the one through the center, but this time around you cannot draw the line straight through the back, stop here. Just simply stop the line here. So this will be the line then. And then draw the diverging line. Draw the diverging line. So the diverging line from the first ray just now should be from the focal point at the front, goes through the line there. So this will be your first diverging ray. The second one, where you stopped just now, here. Okay, so parallel to that will be the diverging line. Last but not least, the one at the center just now, just continue towards the back. So these are the diverging lines. And how do you draw the image? From the diverging line, just pull the line towards the back of the lens. So this is the point of intersection, where you can see your image is much smaller. Since it's at the front, it's virtual and also upright. For a concave lens, it's a bit different than convex lens. The image are all the same no matter where you put your object. So let's say you put your object inside F, outside F, more than 2F, or anywhere the object is placed, your image will always be virtual, upright, and diminished. So these are the summary of image characteristics where you can refer to. Please try and do the exercises just now.